This is the Chapter 3 test review sheet, the number 1, that hopefully will get you prepared for the upcoming test on Chapter 3, and then there's a little bit of review from Chapters 1 and 2. So I'm just going to work through all of the 15 problems on this sheet, and I hope this helps you as you prepare for this test. So we'll get started here. This first problem involves using two different methods for solving systems. We're going to first solve by graphing. So let's go ahead and do that. To solve by graphing, we need to change each of these equations. They're currently in standard form. We need to write them in slope-intercept form so we can see what the slope is and we can know where to begin with our y-intercept. So maybe I'll do some colors. This top equation, solve for y, subtracting 2x from both sides, would be y equals negative 2x plus 5. Okay, so let's just go ahead and graph that. That has a y-intercept of 5. So I'm going to go up to 5 on the y-axis. And then I'm going to count a slope of negative 2. So I could do down 2 and right 1. You could have also done up 2 and left 1. Okay, and let's see if we can get the line draw tool here. And we'll do this one in red. And so there is that line. Okay, the other line equation, we need to solve it for y, or in other words, get it in slope-intercept form. We'll do this one in blue. For this one, we're going to need to add x to both sides, so we're going to get y equals x plus 2. So this has a y-intercept of 2 with a slope of positive 1. So we would do up 1, right 1, and up 1, right 1 again. And we'll draw this one with a blue line. And if there is a solution to this system using the graphing method, it's where these two lines cross each other. So we need to show that. Looks like these two cross at the point 1, 3. So using ordered pairs, we would say the point 1, 3, or x is 1, y is 3, is our solution. But I want you to, as the instructions tell you, I want you to use a different method. It really doesn't matter whether you use substitution or elimination. If you used elimination, you probably would just stay with the original system before you solve for y. So I'll just do it both ways. Here are those two equations in my original system. And using elimination says we need to eliminate one of the variables, and I'm going to eliminate y with subtraction. Okay, so subtracting all the terms in my two equations, subtracting like terms, 2 minus negative 1, that's 2 plus 1x, which is 3x. Y minus y is 0. 5 minus 2 is 3, so x is 1. That part checks out. And then I'm going to plug into either one of these for finding y. I'll just plug into the bottom one. Y equals 1 plus 2, so y is 3. So we proved basically that our graphing answer was correct by picking another method, in this case elimination, and we got the same answer. Okay, if you did substitution, that's easy enough. Since they're both solved for y, then you could just let one of these, say the blue x plus 2, could replace this red y. Or you could have done the red negative 2x plus 5 replacing the blue y. Really doesn't matter. So I'm just going to say negative 2x plus 5 equals x plus 2. So this is just an example of substitution. We substituted this red expression in for the blue y in the bottom equation. And now we just solve for x. So if you subtract x from both sides, that's negative 3x. Subtract 5 from both sides, that's negative 3. So x is positive 1. And of course, you would do the same thing to get y. Okay. So we proved it in two different ways. The directions said you could just pick one, and the test is set up the same way. So make sure you actually show two different methods along with, of course, your graphing method. Okay, that takes care of number one. So here's number two. Number two, we have to solve this one using substitution. So please make sure on your test that if it says to use the substitution method, you use that. Even if you were to use a different method and get it right, I can't give you credit unless you use the method that the problem calls for. So when you're using substitution, you should always look for a variable that has a coefficient of positive 1 if you have it. And we have that here. If you notice in this top equation, x has a coefficient of 1. The reason why that's much better to solve for is because we can solve for x, in this case, with one step. We can just subtract 3y from both sides and we're there. All of these others will require two steps. We'll have to subtract and then we'll have to divide. So if you can, look for a variable that has a coefficient of 1, and that makes using this method a lot easier. So we solve for x on the top by subtracting 3y from both sides. And substitution says solve for a variable and then replace that variable in the other equation. So in place of x in the bottom equation, we're going to put negative 3y plus 2. And we're going to solve for y. So I got to distribute negative 9y plus 6 plus 3y equals negative 6. Negative 6y plus 6 is negative 6. Negative 6y is negative 12. So y is 2. Okay, and now to find x, you have choices, but it makes sense to just go ahead and use this equation that's already solved for x. So we're going to replace y with 2 and solve. And so negative 3 times 2 is negative 6. And we got x is negative 4. And so showing our answer as an ordered pair, the answer would be negative 4, positive 2. And if you have time, maybe you finish the test and there's still some time remaining, it's always a good idea just to go back and see if these two numbers for x and y, if you plug those into both equations, do they make both of the equations true? And if they do, then you'll know you're in good shape. Okay, so that takes care of number 2. All right, number 3 is also substitution. So I'm surveying the system and I'm looking for a variable that has a coefficient of 1, and we have that. And so that's the one I'm going to solve for. I'm going to solve for x on the bottom this time by adding 3y to both sides. Okay. So there is the solve for x on the bottom, and now I'm going to replace the x on the top. So negative 2 times 3y plus 3 plus 5y is negative 2. Distributive property, negative 6y minus 6 plus 5y is negative 2. Combine like terms, negative 6 plus 5y is negative 1y. Minus 6. Add 6 to both sides. And we get our value for y. Okay? And so the shortest route to finding x would be to just use this equation that's already solved for x. So x is going to be 3 times negative 4 plus 3. That's negative 12 plus 3. x is negative 9. So our answer in order pair form is negative 9, negative 4. So that's the substitution method. And now you've got a couple more where you have to use elimination. Okay, so look at your variables and see if you can determine which variable looks like it would eliminate the easiest by using addition or subtraction of these two equations. Well, as you can tell, with addition or subtraction, neither variable cancels automatically. But it's pretty close right here. If we just change 3y into 6y or negative 6y, then these would cancel depending on whether you made it 6y, you could cancel with subtraction, or negative 6y, you could cancel with addition. I've noticed most people like to treat these as opposites so they can add. So I think I'll do the same thing here. I'm just going to multiply by negative 2 just on the bottom. I'm not going to do anything to the top equation. I'm going to show negative 2 on both sides of the equation because sometimes people forget that you're also supposed to multiply the constant on the right side. So nothing is happening to the top equation. I'm just going to rewrite it. But the bottom equation, after being multiplied by 2, becomes positive 4x minus 6y, and that equals negative 30. Okay, so addition will eliminate y. So 5x plus 4x is 9x, and negative 24 plus negative 30 is negative 54, so x is negative 6. Okay, so once we found x, now we can plug into either one of these in the system and we'll find y. So maybe we'll go to the top equation. 5 times negative 6 plus 6y equals negative 24. Negative 30 plus 6y is negative 24. Sorry about that. And then we're going to add 30 to both sides. 6y is 6, so y is 1. So our answer is an ordered pair. X is negative 6, y is positive 1. Okay, and then once again, it's always a good idea to check these answers. Make sure, if you have time, on the test. And this, if it's right, should make both of these true. And it does. Okay, this one's a little different because I can't just multiply by one equation only to make x or y cancel. So I'm just going to make a choice here. I'm going to eliminate y by multiplying the top equation by 3 and the bottom equation by 2. And that's going to create opposite terms here. This is going to become negative 6y, and this will be positive 6y, and then I can add them to eliminate. But don't forget, though, to multiply by everything in the equation. 3 times 5x, 3 times negative 2y, and 3 times negative 19. And now multiplying by 2 on the bottom, 2 times 2x plus 6y, and that's 0. Okay, addition will eliminate y. 15 plus 4x is 19x, and that's negative 57. So of course x is negative 3. And then you pick either one of these to plug x is negative 3. I'm going to go with the bottom. 2 times negative 3 plus 3y is 0. That's negative 6. 3y is 6, so y is 2. So our answer, ordered pair, negative 3, 2. All right, we are moving right along. Let's try number 6. Now we're solving a system of inequalities. We just finished solving systems of equations. Solving systems of inequalities the solution will be a shaded region, if there is a solution. It will be a shaded area that represents all of the ordered pairs that make both of these inequalities true. Well, just like you graph lines, we're going to start off that same way graphing these inequalities. We're actually going to graph what is known as the boundary line, and then we're going to decide based on the inequality which side of that line to shade. Okay, so let's just do this top one in red. So let's go down to -6 on the y-axis. 1, 2, 3, 4, 5, 6. That's my y-intercept, and I've got a slope of +3. Up 3, right 1. Up 3 and right 1. This is a solid line because it says or equal to. And with your straight edge, oh, I said solid line and I chose dotted. All right, so there's the red line. Now, if you don't want to shade as you go, some people do, the less than side of any line with slope like this is the lower or the underneath, the below side. I'm just going to show with arrows. The shading for the red line would be this way. Okay, now let's do the other one in blue. This one has a y-intercept of 2, slope of -4, so that could be done as up 4 and left 1, or you could do down 4 and right 1. Okay. So here's our blue line, and the shading, probably should have made that a little bit longer. Let's try this. Yeah, that's better. And the shading for the blue, this blue line, is greater than, which means above. So for this line that has a slope like this, the greater than side is the upper side, the above side. Okay, so what I'm interested in when I'm trying to find the system, the solution to a system of inequalities, is where do the red and the blue shadings collide? What area do they share? And where I have red and blue together is right here. Red would continue if I extended these out. You could even make like a little patchwork design, I guess. You see how if I extend red, then red and blue cross over each other, and that's what I'm interested in finding out. That represents the solution to a system of inequality. So all of this area is the solution. Any ordered pair that you wanted to pick in the shaded region will make both of these true. Okay, let's try this one. This is a combination of a linear inequality with an absolute value inequality. Alright, so we'll do this one in red. This boundary line y equals 5, remember this represents the y-intercept. So let's go up to where y is 5. And the only way to draw a line that crosses through that point only, just that point, well, it's going to have to be horizontal. So this is the line y equals 5. Just realized, did I make... Yeah, I just thought, sorry about that, I just caught myself. This blue one should have been a dotted line. So if you'll bear with me for a second, I'm just going to replace that. I'm sorry about that. See, it's easy to make mistakes. Little mistakes like that. everything else is okay. Okay, so be careful when you don't see the or equal to. That means you obviously have to have a dotted line. Okay, and that's also true here. It's true for both of these actually. So let's do this line in red. This is the line y equals 5, and it's dotted. And the less than side for this line will be under here. Everything heading this way below the line. All right. Now let's do this absolute value in blue. Remember, if you have an absolute value function, it has to produce a V shape. Don't forget the V in value. So this V shape, it has a vertex. And we've got to get out of this mindset of every time we see absolute value, we think we can just translate by moving the parent function. Well, this is not a parent function here. The parent functions that you know for absolute value are y equals x, or the opposite of the absolute value of x. And this is not a parent function because it does not have a coefficient of 1. So in situations like this, you can't just say, I'm going to go left 1. You've got to use that formula to find the vertex, the opposite of b over m and c. So again, here's m, here's b, and c will be this constant out here. If there isn't a constant, then it's understood to be 0. So the x-coordinate will be the opposite of 1 over 2, which is negative 1/2, of course. And that's right there, just to the left of the origin, a half a space. And now to make the rest of the V shape, I'm going to look at the number in front of x, the slope, and I'm going to count up to right 1, up to right 1, and then I'm also going to do up to and left 1, because obviously to make a V, I'm going to have to count the slope both as a positive and a negative. Okay, so again, a dotted V, because it doesn't say or equal to. Okay, so for the V, it's greater than. And greater than for the V is above, actually both lines. There's 2 lines in the V. We're just going to shade above both. Okay, so even though I'm showing shading for the blue forever and ever, my solution to the system is only where blue and red meet each other. So hopefully you can see that's underneath the red dotted line and then inside the blue V. This is where red and blue mesh, and that represents the solution. Any ordered pair in that shading will make both of these inequalities true. Okay, moving right along, we've got this. This is actually, I cut off the number there, but this is number 8 on your review sheet. This is our linear programming problem. So it's really like what we did before with this problem. It's just a little more involved because we've got more lines, more shading to do. So the first thing that has to happen is we need to get these in slope-intercept form. So let's start with this one. We're going to subtract x from both sides. Okay, now it's ready to graph, so y-intercept of 6 and a slope of negative 1. Okay. Forgot to change my line back. Okay, I need to line that up a little bit better. Alright, so that's the blue line. Now let's do the red. We're going to solve this for y by subtracting 2x. Y is less than or equal to negative 2x plus 10. So this has a y-intercept of 10, so we're going to have to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll just call it right there. And a slope of -2, down 2 and right 1. And I'm not lining these up very well, am I? Alright, that looks pretty good. And now we've got these other two that are pretty common in linear programming. It applies mostly when we're making things. If this represents making two different items, we're not going to make a negative number of either item. So we typically draw these lines just to keep our shading all confined in quadrant 1. So there's x equals 0, and here's y equals 0. Okay, now let's think about how these would be shaded. For the blue, it's less than, and less than is below the line, so we're going this way. Okay, so my blue shading is heading in that direction. The red is also less than, so it's also heading in this direction. And I realize that I don't have any blue in this area, so where I have blue and red meeting is underneath the blue line. Okay. For green, both greens, for the vertical green, the shading is greater than, so that means to the right. And for the horizontal, greater than means above. So blue, red, and green all converge in this space. And that space, make sure you do shade it, that space underneath the blue line and between the green lines, this little triangle area. This is called the feasible region. Okay, those red, everything's getting a little confusing probably, so I'm going to erase the red so we can get a good look at what that feasible region looks like. Hopefully you saw why the feasible region is here. Okay, so we graphed, that's called the system of constraints, and we graphed it. And now let's do this. Let's name all the vertices. Well, vertices are points of intersection. Two or more lines that cross each other on the edge, the outside edge of the feasible region. And I'm noticing that one of my lines might be off just a little bit because I'm supposed to have 4 vertices. So let me check and see. Maybe it's the blue line. Yeah, I'm just noticing it's kind of tough for me to, on these small graph sections with this board, I'm realizing I didn't do a very good job with my blue line. It really should be crossing out here at 6. So I'm going to see if I can just tilt it just a little bit. Make it work. Yeah, I think that's okay. Because looking back at our answers, we should be crossing at, the red should be crossing right there at 5, 0. This is the original answer. This is much easier if I have the bigger graph paper. It's easier for me to draw these lines. But maybe just by looking at this, you understand how to draw the lines, get them in slope-intercept form. This might be a little bit easier to look at than my little graph. And so I think if it's okay with you, I think I'll just go back to the big graph that I've already drawn, because this is getting a little bit congested. So anyway, you saw how we drew the lines and how we did the shading, and now we're going to name the vertices. Okay, so again, vertices are on the edge of the feasible region, the yellow or gold region, and where two or more lines cross each other. So you would not identify where blue and green cross each other as a vertex, because that's not on the feasible region. Okay, so the test is going to say list all the vertices, and so that's what we've done here. And then it wants to know in this problem which of these vertices, this is x and this is y of course, which one would maximize the given function. And that will be provided for you. Here's the function. So you just take each one of your four, in this case 4 vertices, there's that one where blue and red cross each other, and then you've got this one up here. Plug each of those ordered pairs in for x, y, and you'll see which one gives you the highest number for p. So sorry about how that turned out. That's really kind of small, and I'm not really sure that helps you a whole lot, but taking a look at this is much better. Okay, so you can see here how I took each one of these vertices, plugged into the function that was given, and the one that gave us the highest value for p is the 0.50, so don't forget to identify that point. Okay, I hope that helped. Let's move on to number 9. We've got these two different plumbing companies, and maybe we're trying to decide which one we're going to pick, and they charge a little differently. This one called Fix It Fast charges $25 just to come to your house. That's what it means for a house call. And then once they get there, if we hire them, they're going to charge $50 for each hour spent. Once again, I hope you're getting used to seeing these phrases that represent slope. The cost here is represented as a fixed cost, not going to change, and then the rest of the cost will change based on how many hours this company works. So this is just another way of representing the slope of the line, and this one-time fee that's never going to change our cost is like the y-intercept. Do it right is similar. It's a little different. The house call is a little bit more. They're going to give you this one-time fee of $35, and then from there it's based on how many hours they work for you. So the cost is going to change constantly at this rate. So again, that's just another way of saying slope. So here we're asking this last sentence to write a system of linear equations. So right away you're thinking possibly y equals mx plus b. Write a system of linear equations and solve for how many hours would be spent before these two companies would basically charge you the same amount. Okay, well, it should be pretty obvious to you in this linear equation, x has to represent a number of hours. Because if this represents my slope, 50 times 50x, x represents hours, 50x and then plus b, which is the y-intercept. And the same thing here for do it right. $45 for each hour, 45 times hours. Alright, so x in this problem will represent the number of hours, therefore y will represent their cost, or how much they're going to charge us. Okay, so let's just write two linear equations. Here's Fix It Fast. I'll just abbreviate it like this. Their cost is determined by a certain amount per hour, 50 times every hour, plus this one-time fee of 25. The do it right, their cost will be based on this rate per hour, 45, and then this one time, which we identified as the y-intercept. Okay, so here's our system, and we get to pick either method. I would probably say that substitution might be a little easier because both of these are solved for y, so you could think of it this way. This could replace y in the top equation. So we're going to solve. They want to know how many hours. So we're solving for x. So 45x plus 35 equals 50x plus 25. Subtracting, we can subtract 45x from both sides. That will be 5x. Subtract 25 from both sides. That would be 10. And we get x is 2. So putting this into context, after 2 hours, they would charge the same amount. And the problem doesn't ask for that amount, but it's easy enough to find. All you have to do is go to either one of these and let x become 2, and you'll have it. So it looks like that's $125 that they'll charge you for both of them will charge you for 2 hours work. Okay, so that is your answer for number 9. You should know how to set up the system and then solve it for the variable that's being asked for, in this case hours, which is our x variable. Okay, here is our number 10, and it says to solve with either substitution or elimination, so I guess I'll do both. Let's just do substitution first, and substitution means that I'm going to pick a variable to solve for. My best candidates are the ones that have 1 as a coefficient, so really any of these are good choices. Really doesn't matter which. I think I'm just going to go up to the top, and I'm just going to solve the top equation for x. Okay, so when I solve the top equation for x, I get negative y minus 2z plus 3. Okay, so that means I've got to replace x in the other two equations. Alright, so let's show that. Here's equation 2. I'm going to replace x. 2 times this expression, negative y minus 2z plus 3 plus y plus 3z equals 7. This is a little bigger. Okay, and now I've got to do the same thing for equation 3. Replace x. So don't forget there's a minus on there. Negative y minus 2z plus 3 minus 2y plus z equals 10. Now you just go through the process of simplifying. Distributive property, negative 2y minus 4z plus 6 plus y plus 3z equals 7. Combine the y terms. Negative 2 plus 1y is negative y. Negative 4 plus 3z is negative z. And then move the constant over to the right. And when you subtract 6 from both sides, you're left with 1. Okay, I'll keep this one in red. So now you're distributing negative 1, all three of these. So that's going to be positive y plus 2z minus 3 minus 2y plus z equals 10. Combine like terms. The y terms, 1 minus 2y is negative y. 2 plus 1z is plus 3z. And now we'll add 3 to both sides to move the constant over, and that gives us 13. Okay, so these two equations that remain are going to be put together as a system. Okay, so here's my blue one, and here's the red one. And we are back to elimination. We need to eliminate a variable. Well, I'm going to eliminate y. I'm just going to leave this like it is since these are identical. I'm going to eliminate y with subtraction, which means I got to subtract all the way across. So subtraction makes this 0. Negative 1 minus 3z is negative 4z. And 1 minus 13 is negative 12. So that gives me an answer of z, which is 3. Okay, just going back to this two variable system, I can use z to help me find y. So I can replace either one of these, doesn't matter. So I'll just go with the blue one. Negative y minus 3 equals 1. Negative y equals 4. So y is negative 4. Alright, so now that I've got y and z, I'm going to go all the way to the top, and I'm going to pick one of these equations that has all three variables in it, and I'm going to find, in this case, x. So I think I'm going to go with the top because I've already got it solved for x here. So I could just use this equation and replace y and z. So let me do that over here. X is the opposite of y minus 2 times z plus 3. Okay. The opposite of negative 4 is 4. This is minus 6 plus 3. Negative 2 plus 3 is 1. Okay, so we got our answer. X is 1, y is negative 4, z is 3. Okay, so that's using substitution. Well, let me just copy this, and we'll just make a new slide and we'll work through it using elimination. Alright, so give me just a second. Alright, so I'm just going to erase what I've got here. Just bear with me for a second. I can leave our final answer up there, I guess. And let's just go back through it with elimination. Okay, and I told one of my classes today that I would work on eliminating y. So if you didn't eliminate y when you did this, it really doesn't matter which variable you choose, but the process is what you need to understand. Okay, so eliminating y, I'm going to pair up, I'll just call this equation 1 and equation 2. I'm going to pair up the first two equations. Alright, with the idea that I'm going to eliminate y. I'll have to do that with subtraction if I just leave it like it is. Okay, and now it really doesn't matter which way I go. I think I'm going to pair up 1 and 3. The first one and the last one. And again, I'm trying to eliminate y. Well, it doesn't just automatically eliminate, so to make it cancel, I'm going to have to multiply the top by 2. So maybe I'll go with green on that. So here's the top equation multiplied by 2. 2x plus 2y plus 4z equals 6. Okay, so we don't need this anymore. And I can eliminate y on this side with addition. Okay, so 2 plus negative 1 is positive 1x. Y's cancel. And 4 plus 1z is 5z. 6 plus 10 is 16. Okay, now let me go back over here and eliminate y. Remember, whatever variable you decide to eliminate, you have to eliminate the same variable within each pair. Okay, so subtraction will eliminate y over here. So 1 minus 2 is negative 1x. Cancels. 2 minus 3 is negative 1z. And 3 minus 7 is negative 4. Okay, so these two, the red and the green, get put together. I'll just color code for you. And we use elimination again. And it looks obvious that eliminating x is the way to go. I can eliminate x with addition. Okay, those cancel. Negative 1 plus 5 is 4z. And negative 4 plus 16 is 12. So z is 3. Okay, I'm feeling pretty good about it because that's what we got with substitution. Okay, now use that value of z and find x in either one of these equations. So let's just go with the top. Negative x minus 3 is negative 4. Add 3 to both sides. We got x is 1. Well, that checks. Okay, now you can go all the way back to the beginning. Pick one of these three originals. I'm just going to go with the top one. X is 1. Solving for y. Z is 3. Combine like terms. And when you subtract 7 from both sides, you get negative 4. So we are good. So we found the same answer using both methods. Okay. So again, understanding the process, but please be careful. Be methodical. Show your work. Show your steps. And try to avoid those little errors that cause people trouble sometimes. Okay, this is a review problem. This goes back to chapter 1 or chapter 2. We are graphing this absolute value function, but before I can graph it, I need to solve for y, which means I need to subtract 3 from both sides. And subtracting 3 does not do anything in here. It affects this constant outside of the absolute value. So this gets me my equation in this form. Alright. Well, again, resist the temptation just to say I'm going to go right 8. That would only be true if your function looked like this. You see the parent function in there, absolute value of x. Well, this is not the parent function. The parent function has a coefficient of 1. So when you're not dealing with the parent function, you've got to rely on this formula to find the vertex. Okay, M, B, and C. So it literally says the opposite of negative 8 over 2 will be the x coordinate, and whatever C is will be the y. Well, the opposite of negative 4 is positive 4. So this is my vertex of the V. 4, 3. Okay, now Another part of this v is looking at the number in front of x, the slope. And there's actually two lines branching out from this vertex, so we actually are going to count two slopes, really. One positive, positive 2, and negative 2. Alright, and this will be my V shape. And that's the answer to number 11. So study that formula. Okay, make sure you understand how to find the vertex, and don't forget to look at the number in front of x as the slope for both of the lines that come out of the vertex. One positive and one negative. Okay, here's a review problem also from chapter 2. Write the equation for this line. And the line that we're writing the equation for passes through this point and is perpendicular to this other line. Well, it's good to go ahead and figure out what the slope is of this line. Okay, so let's solve it for y. That's what most people do when they want to know the slope. Solving for y, we get 4y equals 2x plus 7. Divide everything by 4, and we get 2/4 x, which is just 1/2, plus 7/4. So the slope of this line is 1/2. Okay, now let's focus on this line that passes through this point and is perpendicular. I can't stress enough that you are not getting anything else from this equation. So at this point, I don't need this equation at all. Okay, so I'm going to come over here. I am ready to write this equation for the line that goes through that point. So we're using mx plus b, slope-intercept form. We know what to plug in for m. We also know, based on this point, what to plug in for x and y. What we're trying to determine, we have to solve for, is b. Okay, so y is -3. We said that the slope of this line is 1/2. So for lines that are perpendicular, they are opposite reciprocals of their slopes. Perpendicular lines have opposite reciprocal slopes. So for this red line, it has a slope of 1/2. That means my slope for this blue line that's perpendicular to it must be -2. You flip it and you change it. Okay, so this is going to help me solve for b, the y-intercept. -3 equals 2 plus b. Subtract 2 from both sides and you get -5 is b. Okay, so here's my final answer. Y equals 2x minus 5. Sorry, -2x. I have the -2 here, but I was looking at that one. Okay, -2x minus 5. So again, I can't stress enough how you find the slope of the line that's perpendicular. It's the opposite reciprocal slope. So find the slope of the given line, flip it and change it, and then don't come back to this equation for anything else. Don't use the y-intercept. You are basically done with this once you've determined the slope that you're going to need for your line. Okay? All right. Let's look at number 13. You have these two functions, f of x and g of x. And all this means is find out what f of -3 is, find out what g of 4 is, and those two numbers that result, you're just going to subtract them. Okay? So let's start off with what f of negative 3 is. Well, that's just going to the f function and replacing x with negative 3. Okay. So when you multiply these together, negative 3 times negative 3, that's 9. Alright, so f of negative 3 is 14. Okay, well over here let's do g of 4. And that just means go to the g function and where you see x, replace it with 4 and simplify. Okay, we got to do the part that's inside absolute value first. So negative 5 times 4 is negative 20 plus 2. Negative 20 plus 2 is negative 18. And don't forget, we have to do the absolute value of negative 18, which is 18. Okay, so we found f of negative 3. We found g of 4. And this says just subtract those two numbers. So my final answer will be 14 minus 18. I've got to do them in that order. F of negative 3 minus g of 4 to get to my final answer, which is negative 4. Okay, let's try number 14. This is a direct variation problem, and remember, direct variation looks like this when it's in equation form. Y equals some number called the constant of variation times x. If you want to know what that number is, okay, just take the y value that you're given and divide by x. Okay? Well, in this case, we're told that y is 15 when x is 12. So that makes it pretty easy to find k. Y is 15, x is 12. Now you could go ahead and reduce this if you like. You notice that 3 goes into both of these, 5/4. Okay, so now that I know k, I can go ahead and write the specific equation for this direct variation. Now on the answers before, I just left it as 15/12 because I eventually changed it into decimal form, but we can just, it's fine either way. Alright, so this is our equation, or you could have had 15/12 here, that's fine. Well, now how do we find x if we're given a certain value for y? Well, let's replace y and we'll solve for x. And to solve for x, I'm going to multiply both sides of this equation by the reciprocal of 5/4, which is 4/5. Okay? And let's see, that's 128. 32 times 4 is 128/5. And then the decimal form of that, I don't have my calculator with me, so I'll just pull that up so you can see it. This is 128/5 is just the reduced form of that. So this is not something that I would give you on your test, big numbers like this, because you can't use your calculator. But you definitely should know how to write the equation, find k. If you can find k, then writing the equation is pretty simple. You just put the number there, and then you just substitute the given number and solve for x in this case. Okay, so the decimal form, I just use a calculator on this one, is 25.6. Okay. So make sure you you can write the equation, find k, write the equation, and then solve. All right, just got one more. This is an absolute value inequality, and remember we said you must isolate the absolute value first. That's always a very important first step. And there are 2 steps required to make that happen. The first one will be to subtract 6 from both sides. And then the next one will be to divide by -3 on both sides. And you have to be careful here because dividing by negative, remember, causes us to switch the inequality. So, you remember that when we have an absolute value inequality, absolute value greater than means or. Absolute value less than means and. So, again, it started off as less than. We're thinking maybe we have an and compound, but as we solve or get the absolute value by itself, it actually became or. So we're going to write 2 inequality statements. Notice nothing changes inside the absolute value when I write the 2 statements. I'm going to let the absolute value be greater than or equal to -3, or I'm going to let that same expression be less than or equal to +3. And I solve for each one. I got greater than or equal to -5, less than or equal to 1. So what does the graph of an or compound look like? Well, it's 2 different lines in this case. Here's 0, here's 1. Okay. All the numbers less than 1, including 1, going this way. And we'll just say -5 is over here. All the numbers greater than -5, including -5, going this way. Well, if this had been an and, we would be talking about where these 2 overlap, and it's only those numbers in between would be the solution. But when it's or, you can think of a combination of these 2 lines. Just take these 2 sets of numbers represented by the 2 lines and put all those numbers together in one set. When you put all of these numbers together with all of these numbers, what you have is all numbers, period. Every single number there is. And the way we express that is just by saying all real numbers. Okay? Well, I hope that helps. That is this review sheet, and I'm hoping that this will maybe answer some questions you have, but I'm still available. If you're still not sure about what to do on any of these problems, I encourage you to practice this, and then the review number 2, go back and rewatch some homework videos, rework homework problems, do your best to prepare, and hopefully it'll show up in a really good grade on this next test. So let me know if I can help you.